Hello, my name is Ross Thorn. I am a cartographer at Stamen Design, and today I'm going to be talking to you about an open source cartography toolkit that we developed for lots of our mapping projects. My co-author on this presentation is Alex Parlato, a design technologist at Stamen, who did a lot of the work for this toolkit. So at Stamen, we make a lot of maps and all different types, from dashboards to any sort of other mapping data visualizations. But today I'm specifically going to talk about vector web maps. And I'm sure there are differing levels of familiarity with vector maps, but there are some great resources out there about vector tiles and vector map technology, including talks at past conferences and some stuff on our blog as well at stamen.com/blog, where we've written about this as well. In short, it's a core part of modern interactive cartography, and there are a few key things to know for this talk in particular. So instead of breaking up the world into tiled rasterized images on a server somewhere, it's broken up into tiled data, and that data is then sent to your device. There are lots of open source maps, and these tools that I'm going to talk about today are built on Mapbox and MapLibre vector map technology. So a JSON file is sent alongside with that data and tells the data how it should look. So here's a little code snippet example that makes the water blue. This is how we often work on these maps. We're doing style sheet vector cartography, editing text files to make an app or browser render the map the way that we want it to. And this is how a lot of the biggest base maps that you see work. And we've been fortunate to have a hand in building some of those big base maps in the past few years. Maps for social media, ride service apps, and one of the world's largest data hosting platforms as well. It's a unique type of cartography, vector cartography, with a unique set of challenges. In a given vector map, there are dozens of data layers, potentially from different sources, that are appearing and disappearing, changing over every zoom level. So we're trying to achieve a cohesive design across these data and across the zooms. You might need to make multiple maps that are built on the same data but styled differently, for instance, like a light version of a map and a dark version of a map. And to effectively and efficiently make several maps, your tools need to allow you to explore new options and style choices, quickly iterate on those choices, and often collaborate with colleagues to make the best map that you can. So during many of our projects, we've developed 3 open source tools that foster these core tenets of exploration, iteration, and collaboration that I'm going to talk about today. We also have other ones, one called Figma Set that was given, we talked about at a past NACIS. You can find that on YouTube and on our blog as well. And we know many of the folks in this industry value these same principles, whether as independent cartographers interfacing with clients or small teams working together to create maps, which leads us to why we wanted to open source it. So Stamen has a long history with open source projects, from our toner, terrain, and watercolor styles to the field papers. They all live in public repositories, and we think it's valuable to contribute to the greater mapping community. So by adding small tools to an open source ecosystem like this, we encourage others to do the same, giving us and anyone else with limited resources the ability to piece together a solid suite of tools. All of the tools that I'm going to show today have public GitHub repos that I'll share on each slide. Some of them have longer URLs than others, but you can find them all at github.com/Stamen. And to illustrate these tools, I'm going to showcase our vector recreations of toner and terrain styles. As a side note, we're discontinuing the service of these original raster maps, and they'll no longer be usable after October 31st of 2023. But in preparation for this discontinuation, we used these very tools that I'm about to show you to make vector versions of these maps. And we managed all of these projects collaboratively in GitHub, treating them like classic software projects. So we're pulling branches, making map changes in style sheets and JSON editing texts, and reviewing each other's work. These tools are integrated as a part of our GitHub repositories and have automatic actions that populate the tools with the style sheets when we make pull requests, which is really slick. And it's possible for anybody to do. And this brings us to our first tool. This might be familiar to some folks who's used version control system like GitHub before. It's our style diff tool. The GitHub repo is in the upper right-hand corner. And it's not much different from a classic diff view in a text editor for GitHub. It's just more aware of the layout of a style JSON and how those rules work in the Mapbox ecosystem. So it parses the information in a more meaningful way. You can compare your style changes that you made to the way it was, and your colleagues can as well to get a second set of eyes on it. This tool is live. You can find it here at this URL, and I'm going to show a quick demo as well. So when you go to that URL, you're greeted with this home screen, and you're able to copy and paste style JSON URLs here before and after. So I'm going to grab a couple of our recent changes that we've made to our toner style, and I just copy and paste the URL right there, press enter, and it loads the JSON. And I'll get the next one here too. And I'll press enter and it automatically computes the diff. So it's showing a couple of things that have changed. We've removed some layers, we've added some layers, and renamed a couple layers as well. And some of the layers are the same, and it shows us the changes that were made within those. So for instance, some line widths, some line dash arrays were removed. Other line widths changed as well, and the max zoom for a certain label was changed. So I'll show this in another tool coming up, but here's just a quick diff look at how the code in the style sheet actually changes. And our next tool is called Mapperture in the GitHub repos in the upper right-hand corner. And it's a core tool for our Stamen cartographers. So it's a side-by-side viewer that allows you to compare multiple maps at a given location. We use it to preview style changes when developing, simply by setting it up to refresh when the style sheet changes in our code editor. It's also integrated with GitHub for cartographic code reviews, and it offers a few different viewing options: a mirrored view, a swipe view, and a phone view. So it's great for sharing internally with your team, or as well with stakeholders and your clients as well, to see how the map actually changes between different iterations. You can find this at stamen.github.io/Mapperture, and I'm going to show another demo of that as well. So when you load that, it loads a couple Mapbox styles by default, and there's a couple other presets too, OpenStreetMap, and it comes some of the legacy Stamen styles that should be getting updated here shortly. And the first view you have is this swipe view. So right now we're looking at Mapbox Streets and Mapbox Outdoors, and there's not a ton different, but you can see that there's a desaturated palette. And what we can do here is highlight differences, and it shows us all the things that are different. So we can see, okay, there's contour lines, there's some color differences and some shield differences as well. A couple of these other handy little checkboxes are tile boundaries and label collisions to help troubleshoot some style when you're working on them. I'm going to show you the style sheet changes from the diff viewer in Mapperture now. So we can see here a before and after. This is how the style looked before, and this is the change that I have made since. So these are pedestrian roads, and I've changed their styling, and we can easily swipe back and forth to see that change. We can also go to our mirror viewing option that shows just a reflected view, and so we can see them side by side, seeing the whole scope of the map. Additionally, you can pull up a phone view to see how it might look on a mobile device too. You can also add another pane. You can add a number of different panes, comparing lots of different map styles, as well as copying an image out of here to then share as a static image. The final tool that I'm going to talk about today is called Cartographer. The GitHub is in the upper right-hand corner, and it is a perfect marriage of Stamen's love of maps and data visualization. So what you can do is drop a style sheet JSON in there, or again, copy it from a URL, and it parses out the rules and shows you how the map symbolizes them side by side. I find this tool particularly useful right at the beginning of a project. So after we've done some rapid prototyping of a style, to identify the areas that might need the most work, and at the end of a project to tie up any loose ends or identify tweaks that'll help the style be more uniform. Additionally, you can export this visualization as an SVG to store for later and draw out the colors for other design workflows. So we will often do that and bring it into Figma and go from there, or it can help make a legend as well. It's sort of a great tool for starting that. And I'm going to show a demo of that. You can find this at chartographer.stamen.com. And here is the first page that you are greeted with. You can, if you've got a style JSON on your desktop, you can click and drag it there. Otherwise, I'm going to paste a URL up here. This is going to be from our terrain style. And it automatically calculates how the map looks. So there's 3 different tabs up here: the fill tab, the lines, and the typography. And I'll go through all of those. So first, we've got all of our fills here. And so we've got a lot of terrain is about the land cover and the natural features. So we have a lot of layers that are dedicated to that. And we group them and sort of separate them as they go, as you zoom in, which is represented by these numbers at the top here. So from 0 to 24, that's the zoom levels. So we can see how things change over zoom, how some things are brought in later at different zooms, and yeah, how they interact with each other and how they look next to each other over the background as well, and how that background is changing. We also have lines. So all of our feature polygons for land cover have outer lines as well that we have a blur on them, and so this shows us how those thicknesses change, as well for roads and other motorways and such. And the final tab is the typography tab. This is actually typography on toner, but we can see all of the places that we've got labels and how they look and how they appear next to each other. And this really helps us to visualize our hierarchy so we know what's important over these zoom levels again. What's going to be most important when we get to zoom 12? What's going to be most important as we phase out of that into a higher zoom experience? And so this just helps us to visualize what our rules are telling us right now and where we might want to change some of that. And so that's Chartographer. Those are all the 3 tools. You can find them again on github.com/Stamen. Here's all the URLs to each individual one. We write more about these on our blog as well at stamen.com/blog. And if you have any questions or comments, please let us know. File some issues, start using these tools. We're really excited to share them with everyone. So thank you.